Hello and namaste everyone. Welcome to Arduino with Sudip, chapter number 6. I know it's taken a long time from the 5th chapter to the 6th, but today we're going to have a lot of fun. We're going to learn about ultrasonic sensors, how to measure distance of an obstacle using an ultrasonic sensor which uses ultrasonic sound waves to calculate the distance between an object to the apparatus. Okay, let's get started. So now we have come back to our old rusty TinkerCAD.com, and we're in the circuits. What we need to do is we need to, just like before, we need to drag and drop the Arduino Uno and just rotate it so that we'll have it in a better orientation. Okay, and now what we do is we will search for the ultrasonic sensor. Ultrasonic. Now we can see there is two different kinds of ultrasonic sensors over here. So one is the ultrasonic sensor that has got 3 pins in it, while the other one is our old rusty ultrasonic sensor at SR04 with 4 different pins. Most of the ultrasonic sensors available in the market is basically the ones with 4 pins. So let's skip the 3 pins, just delete it, and we'll just try out with the 4-pin ultrasonic sensor at SR04. Alright, before we start out with this programming, let's actually know a little about the ultrasonic sensor. What is an ultrasonic sensor? We just click on it, and you see there's a help button right here. It says learn more. Well, once we click on it, you can see there's a lot of things about the ultrasonic sensor given here. So let's just go through it. So the description of an ultrasonic sensor is the sensor uses sound waves, just like I told you before. It uses ultrasonic waves to determine how far an object is from its position. Okay, and how it works, we'll just see. Okay, so what you can see over here is, let's just zoom in. Is this trigger block, and it emits sound waves, ultrasonic sound waves that we cannot hear, and that ultrasonic sound wave gets deflected once it hits an object, and once it gets deflected, it goes back to the other pin, that is the echo pin. So now you can actually sense when you started out the ultrasonic sound wave and when did it reach you in the echo pin, and then you can divide that by 2 because it's covering the same distance 2 times. So if you divide that by 2, you get the actual distance. Now let's see what it says. This device emits sound with very high pitch, so high in fact that you cannot hear it. Sound takes time to travel through the air. This clever device listens for the first echo to bounce off a nearby object. It then figures out how far away the object is by measuring the time it takes for the sound to reflect off the target and echo back to it. Exactly like I explained it. Okay, so connected. So how do you connect it? It's given the connections also. We'll go through it another way. I'll describe it to you. Okay, so now how it is used. So we'll see that too. And if you click on more information, it directs you to other websites that actually have examples of how they've used the ultrasonic sensor. Okay, so now let's get started. Okay, so you can see here it's the first pin is VCC. We all know VCC is the positive pin, so we just need to supply it with power. How do we supply it? We either go to 5 volts or 3.3 volts. What about the trigger? Let's connect the ground first. So once we have the power up, we'll connect the ground pin to the ground, and now we are left with trigger and echo. Now the trigger pin, let's change the color, while we're at it. Okay, let's change the trigger. Okay, sorry, let's change the VCC to red so that we don't get confused. Okay, so the ground is green, and now the trigger pin, let's put the trigger pin as yellow, and let's connect it anywhere in this digital pins, output pins. Okay, so now The next, let's keep it blue. Sorry, this is yellow, and the echo pin is now blue. So let's say the trigger is 8 and the echo is 9. Great. Now we have the connections. Okay, I'll show you something that TinkerCAD does. It's kind of unique and it's very pleasing too. Just click on this. Oh no, you need to start the simulation. Let's just start the simulation. We haven't written any codes yet, but we'll do that later. I just wanted to show you this. When you click on the ultrasonic sensor, it shows an object over here, and like you can see, it's bouncing off the trigger pin and deflected from the object. It goes back to the echo pin. So now, if we move this, you can see the values. Let me just zoom in. You can see the values in inches, and that converted to centimeters. So it's telling you how far the obstacle is. Okay, but now we need to figure that out, and we need to use that output, that as an information. In order to do that, we need to program the circuit. Now, how do you do that? Let's stop the simulation. Let's go to code. So now we know where the echo and trigger pins are connected, right? Now we just need to output whatever distance we have so that we can use that information to do something, right? So we'll go to the inputs, okay? And in the inputs, you'll have something called the read, something like the read ultrasonic sensor on trigger pin 0, echo pin same as trigger, and units centimeters. So this thing actually gives us the value of the distance. Now, in order to store that value into something, we need a variable. So we haven't actually gone through the variable parts yet in the previous chapter, I think. If we haven't, then we'll cover it later. But what you need to understand is a variable is something that actually stores information. That's pretty much it. So what we'll do right now is we'll create a variable, and it says what's the variable? Okay. So the variable name, let's put it as distance, since we're measuring the distance, and we'll do okay. Now see, you have a distance variable created. You can set the distance to 0 or whatever. You can change the distance by 0, whatever. Okay. Now, if we were to actually set the distance at the start to something called say like 0 or whatever initial value you have, you could do on start, set the distance to 0. You can rename the variable, you can delete the distance variable, you can if you have multiple variables, you can select it from here as well. Okay, now we need to extract the distance information and then put it to the variable. So what would you use? We just set distance to how much ever is the distance from the that we gain from the ultrasonic sensor, but we need to change these pins first. Read ultrasonic distance sensor on trigger pin 0. So, but we do not have it at the trigger pin on 0, right? We have the trigger, which is yellow, on 8. So let's do it likewise. So trigger pin is supposed to be 8. What about the echo pin? Echo pin is 9. So it's not same as trigger. It would have been same as trigger if it was an ultrasonic sensor module with only 3 pins, but we have 4 pins over here. So the echo pin actually goes to digital output 9, and it says in units. Would you like it in centimeter or inches? It's up to you. So we'll just keep it as centimeters for now. Okay, so now that is done, we need to find a way to actually process the information and get it out and then display it somehow. Now, where are we going to display the information? For now, what we'll do is we'll learn about something called the serial monitor. If you can go here below, you can just click on it, and the serial monitor. This is a serial monitor. That's what pops up. So we know this Arduino has a serial interface, and it has this chip that actually helps us read serial data, upload new sketches to this microcontroller chip using serial data. So serial input and output can be used to display information. What we'll do in order to display whatever we have, now we have it stored in the distance, right? Now we just need to output the distance variable in the serial monitor in order for us to see. Okay, so we'll just go to output, and you can scroll down over here. So there are different modes of output. What we'll be using is, it's right over here. So print to serial monitor hello world with new line. Okay, instead of hello world, now what do we have? We have the distance variable. Okay, we have already stored the value in the distance variable. Now we're going to output the distance variable with a new line. What is going to happen if you do not use the new line? Okay, we'll see that as well. First we need to simulate the circuit. So we'll just press on start simulation, and we'll click on this guy over here. Right, see, we already have the output coming in. Okay, we'll just click on it, and now you can see that the obstacle is at 176, and that is what it's displaying to us. If you just move this around, so it's at minus 149 centimeters, so it gives us the same output. Now this output can be useful, and we can actually use this output to do something. Okay, we can use it to do something on the computer, or we can use it to do something on the hardware, which is the Arduino circuit itself. Alright, so we'll see how to do that next. But before that, let's just toggle this width to without, and let's see what happens. So we'll just start the simulation again, and just look at the serial monitor. Now you can see it's giving us the value, but it's not going below, because we have written without a new line. So it keeps on going on the same line, and that's going to be very confusing, and it's going to be visually not appealing. So we'll just stop that, and let's start. That goes to with and not without. Alright, so I think we're clear up to here. And now what we'll try to do is, with this useful information, we will just create a circuit that can actually help us determine where the obstacle is located. Okay, say for example we have 200 centimeters to work with. Okay, so if we had 200 centimeters, we are just going to use 3 different LEDs. So we'll just type in LED, and we have, okay, LED. Now we'll need to have 3 LEDs with different colors. Okay, so let's assume the red LED means that we are very close to the circuit, and then we'll have a yellow LED. Yellow doesn't look so good. Let's say we have an orange LED. It looks pale too, but that will be fine, I guess. And we'll have a green LED. So when the green LED lights up, it's supposed to mean that the obstacle is far away. When it comes to the yellow LED lighting up, it means the obstacle is somewhere midway. And when the red LED lights up, it means that it's very close to the sensor itself. Okay, so in this example, we are not going to use a breadboard. We'll just try to use resistors, and we'll just connect it. outside. Okay, so we'll just use a resistor, and you know where to connect it, cathode or anode. I will just connect it to I will just connect it to terminal 2, which is the cathode over here. Let's have another resistor. Let's connect it over there. Let's rotate this guy a little bit. Let's connect it. We'll have another one. We'll just rotate the guy. Connect it. Okay. So this is supposed to go to the ground, right? Well, this is supposed to go to the ground as well, and this is supposed to go to the ground as well. It looks very jumbled up now. Now we can barely see where these things are going. So instead of that, let's do a little trick. Okay, what we'll do is either you can just double click on it, and a node will appear. We'll just double click on it. Wherever you double click, a node appears. So we'll just create another node, and then we'll drag it around. Okay, now this looks much more organized. Not that organized, but at least not as jumbled up as before. We can tell which wire is going. Okay, that's fine. So all of them going to the ground. Or we could also have done this. See how stupid this looks? Because you could just connect it all to this ground over here. See? You have a ground, and it's the same thing. It's the same thing, man. It's not connecting somehow. Oh, that's sad. Somehow it just won't let me. Finally got you. Okay, now they're all connected to the ground. And since we have the ground pin with green wire, let's just convert it all to the green color. Okay, 1, 2, and 3. And now that we've discovered about the nodes, let's make it look pretty. Amazing. Now we're going to connect these pins to the digital pins. So let's do 5, 4, and 3. So the first thing, 3 lights up. If it's far away, midway, yellow, the orange one lights up, which is 4, and then red is when you're very close to the sensor. 5 lights up. Now the red LED lights up. Let's just change the color of all these to purple. Purple, and this one is purple as well. Okay, let's just beautify them a bit. Nice. Now what we're going to do is we are going to program it. Let's go to code, and let's keep it over here. Now that we have it in our site. Okay, so first of all, we are going to program it. We need more space, I guess. So we know that this goes to 3, 4, and 5. Okay, so we already know the distance. We just need to now use an operator and use a little bit of maths. So inside the maths block palette, we are going to go to, so we're going to go to this one, this block. We'll just drag it over here. First we need an if condition. Where is the if condition? And the control blocks palette. So now we'll just put it inside the if and put this on forever. Oh, no. Oh, we need to check two conditions. So if distance is greater than 200, so we have two operators, and so we have two conditions to check. And if distance is smaller than 200, but if distance is, let's just duplicate this, duplicate and put it over here. And if the distance is greater than, if it's smaller than 200, and if it is greater than, say, 100. Okay, so we have two conditions. If the distance is smaller than 200 and distance is greater than 100, which is the farthest condition, we are going to light up the green LED as we talked about it. So we go to output, and then we'll go to, so set pin 6, sorry, not 6, what's the pin number? Okay, the pin number is 3 for green LED. So we're going to use pin number 3, set pin 3 to high. Okay, let's duplicate this entire thing, put it over here. Now the next condition is if distance is smaller than 100 and distance is greater than 50, then what happens? Then we'll light up the yellow or the orange LED, which is set at pin number 4. I'll just duplicate this again and put it over here. Now if we have no, we don't need to check two conditions now. We just need to check one condition, that is if the distance is less than 50. Okay, so this one, so we'll just drag this one over here, and the rest can go to the dustbin. So if the distance is less than 50, which is the closest from the sensor, the ultrasonic sensor, now we'll light up with LED number 5, which is red. Now there is a slight problem with this code. I'll tell you what the problem is, but first let's start the simulation and let's see what happens. What have we done so far? Okay, so we'll start the simulation. Okay, as soon as we start the simulation, the green LED is on. Let's see why. Okay, so we have the distance set to 154 centimeters. Okay, so we said anything above 150 gets the green light. So anything that has a value more than 150, we get a green. So up till 100 to 200 is going to be green, and we need to come below 100, and see, once we're below 100, that's 79.4 centimeters, we get the orange LED light up. Now if we come below 50, the red one should light up, just as we expected. So now the problem with the code that I discussed earlier is that we forgot to actually switch off the LED that's not supposed to be lighting up at the other LED's threshold. So see, now everything is lit up, and then now it's not going to tell us anything. So we're going to know nothing after the first start. So in order to fix this problem, we are going to change the code a little bit. What we're going to do is, when pin number 3 lights up, we will light off the rest of the LEDs that we have. So if 3 is high, 4 and 5 should always be low. Now let's just duplicate it from here and put it over here. Now if 4 is high, 3 and 5 should be low. And let's just duplicate this block, put it over here. If 5 is high, 3 and 4 should be low. Now that should work. Let's start the simulation once again. So we are above 200, that's 206. So our code demands that we light up when the green LED when the distance is smaller than 200 and is greater than 100. But it's once it's way past 200, it's not going to work. So after 200 we are not detecting anything. Okay, so let's just pull it down to 200 and let's watch closely at the green LED. Okay, once we're down to 100 and above 100, the green LED is going to light up. And once we're down 100, okay, let's see, once the orange LED lights up, the green LED turns off. And what about we go down to 50 and see what happens? So once the red LED lights up, the orange LED lights off. Okay, so shuts off. Now see, the same thing. Once we're above 100, so we have the green LED light up and the rest of the LEDs go off. And once we're in orange, the rest of the LEDs goes off. So now what we have just created over here is we have created some kind of a proximity detecting device. So now whatever you want to detect and you want to know where that thing is in your surrounding, you can use this circuit. So you just made a proximity detection circuit or a proximity detection device. How amazing is that? So the code is very simple. The code is very, very simple, and you have and this is working with the block codes. Now let's see what it says on text. Let's switch to text, and wow, there's a lot of things. So there's a function that's taking in the input pins of trigger and echo, and then you have this pulse in, that's another function. You have delay microseconds, and then what does it do inside loop? It calculates the distance by multiplying it with some kind of a number. And well, so it's a little not so beginners friendly when you talk about this code, but we can decode this code and we can see what actually it means in probably the next chapters. So for chapter 6, I think this should be enough. I hope you had a great time. Thank you so much, and we'll see you in the next chapter, chapter 7. Thank you and goodbye.